Good morning. So let's quickly. You got the message, right? Like the class was not there. Everyone has checked the website. Yeah. So first, let's quickly recapitulate what we have seen in last lecture. So yeah, we started off with. Yeah. So we saw analysis of sequential circuits, right? So we found that we can represent the states or the outputs, okay, at different time sequences with the help of a diagram, a state transition diagram, isn't it? That would help us representing a circuit with its behavior. So that is called as a behavior model or state diagram representation. So this taking this course into point of view, the state diagrams are quite important. And also if you go for competitive exams, there will be some questions on this. Many times they ask questions on the state diagram. So we'll take such one question. And we saw that we saw a couple of circuits based on that, right? So the last circuit which we saw was quite different from the first two. The difference was like the output was dependent on the input and also on the states, the behavior. But and on the previous two circuits were like the output was dependent on only the states, not the inputs. So that's how we differentiate between these two. So such kind of machines which take some finite amount of states or predefined number of states, not predefined, I can say we should say that finite number of states are called as state machines. Okay, so let me write that. So whatever the circuits which we have seen are called as state machines, or just because they have some finite number of states, they are said as finite state machines. So whenever there exist these kind of words, should not be afraid, because these are nothing but the sequential circuits, okay, whose output depends on the states and may or may not depend on the inputs. So the first thing which we have seen is called as a it's a Moore FSM. The name of the scientist, Moore FSM, in which the output of sequential circuit depend on the output or the present state, or the next state, you can say next state, present so this may be confusing, so let me write it as present state and the previous one and the same thing. So states or the behavior of the circuits, right? So second is called as a Mealy. Okay, so the last example which we took was from there was the example of Mealy FSM, with output is not only dependent on previous state but also on current inputs, right? So that means this Mealy FSM can change the output, okay, doesn't matter the clock appears or not, isn't it? Because when the clock appears, the state change. But as this is dependent not only on the previous behavior but also So on the current inputs, the input change, the output may change. I mean, irrespective of the clock, right? Because it may happen that the clock is, we didn't provide any clock, but the input changes. Hence the output may change. We may look at the circuit diagram which we have seen last time. The output was taken as an AND combination of the input and the previous behavior of the circuit. So if we don't provide a clock, previous states will be there, and the inputs, if it changes, the output may change, right? So it is independent of the clock. I mean, the output may depend, output may arrive or output may change. Doesn't matter the clock changes or clock arrives or not. So that's the difference between a Mealy and a Moore machine. So let me write that. So output changes with clock, and the output may change without clock transitions. So we don't have to wait transitions. So input changes, output may change. So input change, so output may change. And that's how we can also draw the diagram for this. So Mealy would be having, so in a general structure of such FSMs would be something like this. So let me draw a general structure. So a general structure would be, can you look at the structure? I mean, the examples which we have seen, like we were having structures something like this. We would have a kind of next states combinational circuit. There was some kind of combinational circuit. Okay, so next state combinational circuit. We were having some memory elements. Memory elements. So it is dependent on clock. Okay, so they were the flip-flops, and this was fed to next state combinational circuit was actually modifying the present state of the memory element, and the output we may directly take from the memory element, or we may have an additional the output combinational circuit, right? Output combinational circuit. And this memory element, we may give it back to this next state circuit, so as to there was a kind of, we may have a loop condition there, isn't it? We may have a loop, something like this, and of course the inputs are there. So inputs, isn't it? If you see the circuits which we have seen so far, they have some kind of this kind of behavior. And also I missed something. This one, okay, there was one more, in the output combinational circuit was also dependent on the input. Okay, it may or may not. So this is present in which machine? As I said now, this is in which machine? Which FSM? Just now we saw, yeah, Mealy. Yeah. So this is absent. So this is absent in, tell me, Moore. So this is the typical block diagram of the FSMs. Is that okay? So we take one quick numerical which we have asked in GATE 2012. So let me draw that. They asked an example, so let me take an example on a complete exam, GATE PC 12. So this was something like this. So this is D, Q, Q bar. This is a positive age triggered clock. This X1, X2, Y, and this is select line S. Okay, so this is a, what is this? So if there is a select line, tell me, what is this? A 2:1 marks, isn't it? So this is a 2:1 marks. And the answer, what was asked was, no, okay, let me, now there was a question based on the state diagram. Okay, so you need to, can you draw a state diagram for this? You know, this, the output or the states of this, you know, what is this? H triggered D flip flop that was dependent on, you know, the multiplexer behavior also, right? So the states would change depending on what has been selected, right? Assume that, you know, you may assume some previous data or the previous states. So S, Q may be 0, Q bar may be 1, and so on. But you know, in general, how many states would be there? You tell me. How many states would be present in this? How many states? You saw the concept of states, right? States means, yeah, it depends on how many number of flip-flops are there, right? So there is only one flip-flop. So that one flip-flop may have only two states, maybe 0 or it may be 1. So let's draw that. So can you draw it quick? 0 or it may be 1. So Q equals to 0 and Q equals to 1. Is that okay? Now the task is, like, you know, you need to define those transitions. Can you draw it quickly? How the transitions would be, on what it would be dependent on? It would be dependent on what is the A, right? What is A? So let me simplify the steps for you. So, can you please complete this diagram? Quick. You got what I am saying? So the A here, what is the A here? What is the A here? So A equals to question mark. So there were 4 options, okay, with, you know, different values of A. Can you think of it? Quick, some easy question. Got it? And why they are 2 states? One flip flop, they can only have 2 states. Quick, we need to cover a lot of things today. Draw it quickly, let me see how many you are able to do it. Was for, I guess, only 1 mark. Questions are for 1 mark or 2 mark maximum. और 1 mark का difference आपको 1 question solve करने का 2 mark. इसका difference आपको 1 mark पता चलेगा. Actually होता है कि मैं और मेरा दोस्त जो है 25 साल के साथ में रहे, मतलब one of my very close friends, and we mistakenly have like, और हमारा जो score था वो भी almost same था. मिस्टेकनली उसको पता था ये जवाब सी है, सी है, सी है, उसने सी टिक करते बजाय बी टिक कर गलती, और हुआ कि 2 मार्क तो मिले नहीं, 2 मार्क तो गया, वैसे 10 मार्क का सॉल्व किया, ठीक है, वो गलत हो गया, 2 मार्क तो गए, 8 माइनस 2/3 ऑफ दैट, ओके, सो माइनस 6.67 will go, that means it will be 6.33, इतना मार्क, इतने मार्क से वो 5000 से टिका, 5000 हॉलीडे रेंट, तो 1-2 मार्क की कीमत जो है वो आपको तब पता चलेगी जब आप पे जाओगे. Okay, we have to wisely choose the option, and you know we should be confident that that option will be right. And nowadays they don't provide options. They ask you the value, tell me the value. So can you tell me the values? From here, you tell me first this. What is this? Oh, you didn't write. Okay, what is this? Is that okay? So let me write her answers first. Huh? You got only one, huh? Okay. Can you tell me the others? It's very easy, very easy. You should not take so much of time. Okay, of course B1. Okay, let me write that too. So this one should be 1. Should I write that? Which one? Below that should of course be 1, sure. Not necessarily. Isn't it? Okay, let me write that. Timing. So these are Vedai's answers. So let's see if they are correct. What about the others? So there are again 4 combinations. The others may be 0, 0, 0, 1, 1, 0, 1, 1 and all. Any other answers? कितना सिंपल है, मतलब कुछ भी नहीं है उसमें. आपको पता है डी फ्लिप फ्लॉप क्या करता है, आपको पता है मक्स क्या करता है. You know what is mux? Quick. See, if I tell the answers, means the curiosity is gone. Anyone with full confidence to gain 2 marks? Verify. Think of it. Should I tell the answer? Come on. Quick, guys. You hardly have in 2 to 3 minutes. Already exceeded. It's simple. Anyone? इतना सोच रहे, हे भगवान. देखो यहाँ पे. Just because we need to cover a lot of things. So, see here. So what I asked was, definitely I wouldn't have drawn this diagram also, but just to give a soft start, I have drawn this diagram. Otherwise, you have to go for your own diagram. What I'm saying is, what is this? It will remain. This is the state of this flip flop, right? D flip flop. Now, the D flip flop. What does it do? It will simply retain. It will simply transfer. It's a transparent latch. So whenever the clock arrives, okay, when the positive edge of the clock arrives, it will simply transfer data from T to D to Q, isn't it? So, okay, but even if it transfers when the clock arrives, it will get stopped here. It will depend on what is the value of A. Okay, so okay, I should have drawn. It was small, like this should be 0 and 1. Now the things are quite easy. When this line will be on, you tell me when the output, when this will be in the loop, you tell me when this value of the D will be retained in the same state. When the A is 1, right? So it doesn't matter if D is 0, the A, if it is 1, when D is 0, okay, I mean the output D or Q, when it is 0, if A is 1, it will remain in the same state. When if the D is 1, okay, doesn't matter D is 1 or 0, doesn't matter D is 1 or 0, if A is 1, it will retain the same state. So, if doesn't matter D is or Q is 0 or 1, it will remain in the same state if the value of A is 1. Answer is very simple. So, what should I write it here? Tell me. Yeah. So, it's 1, 1. What about others? So, it's not necessarily the complement. Okay, you don't think of it. Okay, don't judge. See, your understanding, there should not be any gap in your understanding. You should go to the depth of the circuit, like what it represents. Okay, if you understand those things, इसमें है क्या, मतलब कितना सिंपल था ना. अब मैंने आंसर बताया करके सिंपल था, इसके पहले पूछा तो किसी को नहीं आया. तो इट्स दैट काइंड ऑफ थिंग. आई मीन दे सिंपली टारगेट योर कंसेप्ट्स, बेसिक फंडामेंटल्स. ओके, So if you understand it well, आपको पता नहीं था क्या ये क्या है, मक्स पता नहीं था क्या कब एक्टिवेट होता है, पता था, डी पता नहीं था क्या है, पता था, ये स्टेट ट्रांजिशन पता नहीं था, सब पता था, बट आंसर क्यों नहीं आया? सो what was missing was to have a global picture of the circle. Okay, so that's what we have covered here. Yeah. You got the same answer? This one, right? No, but yeah, so you need to, because there are 4 options, and out of 4, you'll definitely have at least 2 options with the same value of A. Because, see, you should say that what it means, if this is 1 means, if Q is 1 and A is 1, then it will change. Is it changing? So that's what it represents. It will change, okay, when the value of A is 0. That is what it means. Because what is this? When A is 0, this Q bar is nothing but it will be always a complement of that. So here Q is 1, so of course Q will be 0 here, right? And that will be selected only if A is 0. Is it okay? किन लोगों को समझ में नहीं आया? Alright, let's go ahead. So this is the correct answer, 2 marks. Alright, so it's only one simple one. So alright, so let's move ahead. So that's what I mean. This such kind of questions you may expect in some competitive exams. So let's go for the next topic. So see, what we have seen so far are nothing but some sequential circuits. Like we have found some application of flip-flops which were like age triggered, and we found that they can be available in 2 ways. I mean, we may have a Mealy machine or a Mooreheim machine, and we may have not necessarily there may be a only some combination of gates. We may have multiplexer, we may have decoders. Decoders we have already seen, right? I mean, binary to gray code and so on. I mean, we have already seen those decoders. I have also given you a homework one. So we may have a lot of combinations, any combination of this. If you know the fundamentals of each of them, you can easily get to the answer. So that's not the only application. The another application is like, so as we have saw, as we have seen that a flip flop is able to save only 1 bit. Okay, but nowadays the memories are available in TBs. Okay, in terabytes and in hexabytes and so on. So if we need to save multiple bits, we'll need multiple flip-flops, right? So that's how, I mean, if we have one flip-flop, we have another flip-flop. As soon as you add another thing, a group of or the array of such flip-flops are called as registers. So let's see what are registers. So a flip-flop can save 1 bit, so that is also called as a 1-bit register. So register is simply an array of flip-flops. Can say capable of storing n number of bits. So n bit register is nothing but, so n bit register is capable of storing n bit register saves n bit of information. Now these registers are very vital or very important in operation. So let me first tell you the diagram. So the first register, simplest possible register would be, we just need to retain the information. Say for example, let's go for a 4-bit register or a 2-bit register. So how it would be, I need to save the bits. ना save the bits मतलब क्या, कौन सा flip flop लूँ आप बोलो? Simplest possible D flip flop. So let's say I am going for 2-bit or a 3-bit. Let's extend some more. Let me go for 3-bit. I need to save the bits, right? Now, see, let me draw that first. So let's draw input outputs first. So this is, how many inputs will be there? Only 1, right? The other will be clock output Q or Q bar, right? So let me draw 2 outputs. Now it depends how you feed the input. Okay, so this is D. Let me write it as D2. There is a meaning for that. So let it be D1. I missed here. And D0 and so on. This will be Q2 bolo bar, Q1, Q1 bar, Q0 and Q0 bar, and of course there will be a clock. Okay. If you need to save all the bits at a time, so that's like a parallel processing. See, so there are two ways to save the bits. Like we want 3 bits to be saved. We have 3 flip-flops. There are 2 ways to go for it. Either you can save 1 bit after the other, or you can save all 3 bits at a time. Okay, that's how these registers are defined. They are defined as this is regarding the feeding in of the circuit, right? Feeding out can again be we can receive or retain or read the data again in 2 ways, either in the serial fashion or in the parallel fashion. Both are important. Okay, there are several applications where we may need serial input, serial output. We may need serial input, parallel output. We may need parallel input, serial output, and we may need parallel input, parallel output. That's how these registers are defined. So these registers are classified as serial input, serial output, serial input, parallel output, parallel in, serial out, and parallel in, parallel out, PIPO. Now, how do we give? Now, see, this is a simple. Let's take one by one. See, so serial input, serial output. Okay, that means serial input. When I say serially, when I say that, see, data may come serially. Example would be. Can you give some example of serial data communication? Simple. Telephone line, DSL line, what we have is having only a pair of lines, right? So there the data comes in series, one after the other. Okay. So if I need to, if I give the input here, let me give the input here. As soon as the first clock or the positive edge comes, it will save 1 bit. Okay. But what about the others? As soon as the next clock comes, the first bit is gone. So let's connect this. What happens then? The earlier wala bit which was saved, that will be saved in the other. Okay, and so on. So we may simply connect this, and this Q bar is not required, and there it will be data out. So, and both of this, all 3 of them, you can connect to. Tell me. So that should happen at the same time, right? I mean, एक के इनपुट पे पहले का आउटपुट जाना चाहिए और वहाँ पे पहले नेक्स्ट इनपुट भी आना चाहिए. So that should happen at the same time instance. So this is such kind of circuit is called as synchronous circuit, where all the 3 clocks, all the flip-flops are receiving the clock at the same time. Such kind of circuits are called synchronous circuits. Okay, synchronous circuits. So see what happens. Let's see, it's be data out. Okay. No. I'll come to that. So let's say the Q2, Q1, Q0. Let the initial states be 0. How can we make sure that the initial states are 0? I told you last time. There are some predefined inputs, right, which are presets and clear. You should never, go for both of them to 0. You should not make both of them as 0. Only either of them should be 0. If it preset is 0, then it's definitely that that value. Okay, output will be 1 definitely. If clear is 0, definitely the output will be 0, and so on. So depending on what is the that is how the active low inputs are defined. What I'm saying is, when preset is 0, output is definitely going to preset. That means the activity happens only if you give low signal. So such kind of signals are called as active low signal. I mean, signal that will do the job, that will actively do the job if you give low as an input signal. So such kind of, let me draw that. So this is called as preset, and that's how they are given. I mean, it's called as, or let me write as preset bar. So this is the active low signal. What does it indicate? When you give it low, what happens? This, let me put a bubble there. PR bar. When it is 0, what happens? This, either you give bubble here or bubble there. I mean, you should not create. So yeah, is this fine? When you give it 0, okay. So let me write that like that. When you give it 0, then the output will be 1 always, right? PR bar when it is 0, PR bar when it is 0, then output will definitely be 1, isn't it? Just because the NAND gates will be having one input as always 0 and in the output will always be 1 and so on. So somehow if we make sure that this outputs are initially all 0, assume that, and let the data be something like this: 1 0 1 1 1 0 0 0, maybe any bit data, 1 0. Let's say this is now we not save. Let's give this as a input data. Let's give this as a input data or serial bits. So what is the input here? Initially the state is 0. Let me draw that also. Yeah, tell me, when now this is the clock. Now the clock is continuously running, right? From 1001, 1011, oh sorry, 1010, 1010, and so on. The activity happens only on the positive edge of this clock. Is that okay? Initially the value is all 0 0 0. Now as soon as the first clock, okay, this comes, first edge of the positive clock comes, this first bit, okay, where it is, where does it appear? Here, right? Now these are all, let me write that. So this is all here. It initially the values are 0 0 0. Okay. As soon as the first clock appears, the value which was 1 here get transfers here. Okay. So this becomes 1. Okay. But what takes as an input to second this flip flop, that is still 0, right? And for this flip flop it's still 0. I mean that 1 which was transferred from the input is only captured here, because by that time, as all three of them are being synchronized, they will receive the previous wala out, isn't it? So this will get transferred here, this will get transferred there, and this will get transferred there. So it's like a shifting which happens. Okay, the data is being shifted. So such kind of registers are also called as shift registers. So it is shifting from towards right. It is shifting. So it's called as right shift register. Okay, right shift serial resistors. So what should I write it here to tell me? So input is what? When input is 1, what happens? Here it will be 1. This will get copied here. That will get copied here. So 0 0. That is gone. I mean that is given out at the output. Okay, the data is gone. Is that okay? Tell me. Now you can complete this. You can complete this. When it is 0, you tell me. And this is 0. Okay. What happens? Oh, okay. So lot of so same thing as similar kind of shifting will happen, right? So let me draw this as an input also. Input. So when now this where yes, we don't give any input. Okay. Oh, this is 0. You can consider. When it is 1 0, you tell me now. बोलो क्या आ गया यहाँ पे? 0 will get transferred. Okay. Let me rub this. Let me demonstrate that. Yeah. What are the values here? 1 0 0. 1 0 0. Is that okay? Now the input has changed from 1 to 0. This is the input, right? 0. Okay. Now this is what the state is. Okay. Clock is yet to arrive. Clock is yet to arrive. As soon as this clock comes, what happens? No, this will get transferred here. That will get transferred here, and the new signal, which is 0, will get transferred here. Just because it's a D flip flop or it's a transparent latch. So what we will expect? 0 1 0. Is that okay? This input will be getting captured here, so I will write it as 0 and this will be 1. Is that okay? This is fine? Understood? So now you tell me how many bits it can. 3 bits at a time. Okay, so I mean it can process any amount of serial information depending on Now what is the input, what is the sequences and so on. Can you complete the table quickly? So 0, 1, 0, 1, 1, 1. You tell me what is the final output. So this will 1, 0, 1 and so on. So you can complete that, no problem. Yeah. So such kind of register is called as write shift, serial in, serial out, synchronous registers. Okay. Got the meaning of synchronous right now? Yeah. Then yeah. So as I said, okay. Let's go for another circuit now. Such kind of, see how it will be beneficial. Let me put some advantage of this. Say you need to transfer a data from one phone to the another. Okay, so what I may have is it's a shift register, write shift. Let me write a shift reg. It's one shift register, and you need to transfer the data from to the another shift register. So you can simply connect, but we don't want the data to be lost. Okay, say for example, you need to copy a file or a Hindi song to someone else, a mobile phone. What you do, you simply share the song, but same song is also retained in your place. You don't cut paste that, right? So what we can have is we can have a mechanism, something like this, where the data will also be transferred and also be retained in the same device also, isn't it? So these both are synchronized with the same clock. Okay. And assume that they have some data. Let's say assume that it's a 4-bit register and may have some value as, let's say, 11, or may have some value as 6. Okay, can you quickly draw for each transition how the states would of these two, A and B would change? Quick, do that. So what I'm saying is, now let us define that this for Q3, or let me write it as QA and QB. Assume that they have the initial values at this 11 means 9. Oh sorry, 8. Is that okay? So this is 6, no? 6. Alright. So yeah, here when the clock is the initial state, we have said that we have saved 11 and 6 in these two, and we need to see how the states are changing depending on the input to the data, or depending on the clock signal. What I'm saying is depending on the clock signal. Here this is the initial value, so let me write that. So initial. So yeah, so as soon as the clock arrives, what happens? You tell me. This is copied here and also here, right? I mean that is also as an input to the first one, right? So what happens? And that this is the output, so that is gone. This is the output. I may write the output there also, no problem. So write the output bit also. Assume that it's 0 right now. So what happens? Now this will serially shift, right? So this 0 will appear here. Okay. Now can you write the values? You tell me values. 1, bolo. 1, 1, 0, 1. Is that okay? That 1 will shift here. So it will be 1, bolo. 0, 1, 1. Is that okay? You check here. Okay. Check this. I mean, this is being shifted serially. See here. This is being shifted serially. Isn't it? And of course, this is there. Is it okay? At the end of how many clock cycles you will receive the same data? 4. Can you check what is the output in the both of them? What is the output here? You tell me. Now this will get shift here. Oh. This will get shift here, and also back to the here. So what is that? 111, 110. Here it will be 1, 101. Output below. Complete that. Complete that. 0, 111, 0, 110. Output will be 1. Next 1, 0, 1, 1, 1, 0, 1, 1. Output will be R2 having the same value 1, 0, 1, 1. Okay, so data is getting copied, and also you have the same, you have retained that data, isn't it? That is how it happens in cell phones, or whenever you need to share the data. Now this is happening serially. So that is one of the applications of serial input and serial output resistors. Okay, when you simply need to copy data in some the other peripherals or the device, this is how it happens. Is that okay? So it's a nice example of. Of course, it will be dependent on time sequence. See, it's a. Of course, I mean that's how the time period or the time remaining is defined. So, say for example, you have 4 bits, will require 4 clock cycles, and depending on how fast your clock is or how fast your processor is, it will say that okay, 4 seconds are required. Say if it is 1 hertz clock signal, so it may say that 4 hertz or 4 clock cycles are required, and that's how it will display the time. Okay, time required for transfer. I mean it doesn't happen instantaneously, right? USB is another example. Okay, universal serial bus, which we use it widely. Ye dongle wala. This USB is again a universal serial bus. Okay, the data communication happens serially. That's how it happens. It doesn't save. Okay, but the copy is retained in the memory device which is there inside this, okay, while transferring the data. Example of CISO. All right, let's go ahead. Now let's go for this is serial input, serial output. Let's go. Yes, please. Previous, please. How you have written the output? Okay. So this is going to shift or transfer the data, okay, only when the clock arrives, right? So this is the clock. So I have assumed that this is the clock. Like a pushing mechanism. So for example, there are some these people are there, boy, girl, and so on. Okay. Output at the end is this person, which is already a girl. When someone arrives, okay, when someone arrives, okay, what is the signal which we have given? Now I need to simply transfer all the boys and girls from this to that. I need to simply transfer that, and also I want to make a copy that that those boys and girls were present. Okay, I want the initial state also. What happens? Whenever the clock signal comes, this boy will go here, just because the shift register and I connected that, it will simply get the input from the first one. That's how we have seen in the previous circuit. Just because it's a 3-bit or a 4-bit resistor, okay, so it can save only 4 bits. Okay, the last bit which was there, it will be transferred as output. I mean, output depends on you how you take it. I mean, I'm simply writing what the values would be here. After shifting, the previous data bit, okay, which was there in the previous flip-flop of that, or the third flip-flop, will get transferred here. That means last was the girl, right? Yeah. So input. It's up to us. I mean, I'm transmitting the data. Okay. I'm simply transmitting. That means the data is available. To capture it or not, it depends on us. It's getting copied. No. After 4 cycles, it is getting copied. After that, you should not be doing that. After 4 clock cycles, see here, after 4 clock cycles, data is being copied here. But soon after that, you should not give anything, otherwise that data is gone. 11 to copy 11 to 6, both of them are having 4 bits. So as to, this was the initial state. It was having 11, it was having 6. As soon as you complete 4 cycles, just because we need 4 bits of information to be shifted or transferred or copied, after 4 cycles you will definitely get the same data. What is the use of the output? Okay. So that's what. see when you internet, see when the internet coming, it will simply transmit the data. Okay, so as to capture that those values will be captured in the individual flip-flops of these registers. Okay, now you are imagining that we want this whole bits at the time, right? 1011. So, you know, the bits which we are having 1011, we want whole at a time, right? That's what you are thinking. Like, I mean, data is gone. That's what you are saying. What's the use of that? That's what you are saying.
Before we had some data inside, like output is being first, it was nice, and then output is given.
No, that was the previous case.
So what happened to that 0110?
0110, that is gone. When what happens if you have only 5 MB of space and you have a Telugu song there, and if I transfer the Hindi song from my side, that Telugu song is gone, right? Because just you have only 5 MB of space there. Okay, let me. Is it not understood? Okay, let me show that. Assume that there is a 2.117 KB of file. Now this is the file, right? Which was modified, some 8:50 AM. Okay, so this was modified. Sorry, so it was like saved or transferred at some time. Okay. Now, just when we do that, okay, when we copy this, the data to this next file, what does it ask? Either you need to replace or skip this file, or compare both files, or you can rename those files. That's how you represent it. Just because you have the same space, right? You need to. It is having. Assume that this is a register. 2.11 KB of register you have. Okay. Assume that you are only having 4 bit of space. You need to save the data. Okay. Assume that the contents. Assume that what I'm saying is this content of this file is different from what is this file, but the space is same. When you copy that, okay, you need to replace that. Otherwise, how it will copy? Okay, just because the space is same. Okay, so when you replace that file is gone. If you want to make a copy, then you will require few more registers. That means the file space would be 4 twice of this space, right? That is gone. If you need to, that is how the copy happens, man. That is how the copy happens. If you need to retain, then you need to give some special instruction saying that okay, you retain both the copies and so on. I did some kind of goofing. If you can track me, yeah. I did some kind of goofing. If you can track me, I just demonstrate something. Okay, to demonstrate the concept, but I did some kind of goofing there. Okay, leave it. So you got the concept, right? Oh, don't worry. You don't worry. Okay, the concept is if you have the same memory space, you can save only unique 4 bits. Unique in the sense only 4 bits you can save. Okay. All right, so that is gone. Yeah. So if you need to capture or retrieve the data, you need to access all four of them. Right? That's what what is your interest is. The data which was captured was complete 1011, and what we received serially, right? But say for example we need to access all 4 bits at a time. That's how the serial input and parallel output is. Okay? You feed the data or insert or copy the data or receive the data serially, but once serial copying is happened, shifting is happened, all the data is available at a time. How can you have that? Can draw the circuit for that? It's very simple. Okay. And draw the circuit for, what I'm saying is, you need to draw the circuit for serial in and parallel out. SIPO. Draw it quick. We need to cover a lot of things today. Please cooperate. Do you have a lecture after this? No? Thanks for that. I'm going to take that. Alright. So you need to feed it serially, but once those, how many clock cycles are required, you tell me here. To feed all, now how many bit of information it can save, you tell me first. Only 3 bit of information. Let it be D2. Now you got why I'm writing in that fashion, D2, D1, D0, just because the last bit is getting, or the MSB is getting arrived at the end. Right? So D1, D0 is Q, Q bar, Q, Q bar, Q, Q bar, and so on, and let the output of this. Now see, let all of them be synchronized. You need to feed serially, and also you need to take the output, right? So what I can do is I can simply retain the circuit something like this. Okay, so let this be data in. Can you tell me where the output should be taken from? No, at a time I want, so I should take out 3 different terminals, unique terminals. This, take it from here, there. So here you will get Q2, Q1, Q0. But when? Now that is important. But when? When you will get all 4 of them valid data, when you will get? When all the 3 cycles are completed. Only after the completion of 3 cycles you will receive the correct, you can retrieve correct data. Is that okay? So yeah, an example of this. Can you tell me an example of this? Say for example you need to glow all 4 LEDs in some fashion. Let's say first should be glown, okay, another should not glow, first the third one should glow, and so on. So that is what the data I will feed here. Okay. Once the data has been transmitted, at the time I want all 3 of them should follow this fashion, right? So that moment I will simply give the output of these 3 resistors to the LEDs. Simple, right? If you want all 3 of them to operate in some fashion or some predefined data fashion, then we can go for this serial input and parallel. Is it okay? And that's how if you need to go for parallel processing or a parallel addition or subtraction or any arithmetic operation, if you need to give parallelly, then you need to go for such kind of circuits. Yeah. All right. So this SIPO, we'll go for the next. Now this is somewhat challenging. So PISO, you can say, parallel in and serial out. This is somewhat challenging. Can you draw a circuit like this? Please, that's slightly challenging. So take this as a challenge and please draw the circuit. I'll stop it here for this. I'll restart it again.